Okay. Okay, so thank you very much for listening to me talk. I'm going to pass over to my colleague Manuel Krempl from E7 in Austria, who's going to talk about results and lessons.
So hello everybody, my name is Manuel Krempl and I'm working for E7, an Austrian research and consultancy office for energy efficiency. Within the LEAF project, we were responsible for the monitoring and evaluation of the project. I am now presenting you the results of the case study work and what we have identified to be key challenges in improving the energy efficiency of apartment blocks across the partner countries. Within the project duration, LEAF partners have worked with 24 case study buildings with a total of 716 apartments. The building sample varies from 7 historic objects, which were erected before 1920, to 2 buildings built in 1981. Furthermore, 2 buildings are listed buildings. The size of these buildings extends from small blocks with only 4 flats to big blocks with 131, making an average of almost 30 flats per building. Also, the ownership models are different, including totally owner-occupied case studies as well as private rented flats or social housing communities. This is from interest since the composition of the residents can be a crucial factor in the process. The images presented on this slide provide an overview about the achieved results at the end of the project. 10 case study buildings with a total of 246 dwellings have committed to energy efficiency measures. This means that they have either installed measures within the project duration or achieved a decision within the community to install energy efficiency measures, represented in the blue and orange segments. Unfortunately, another 5 buildings with 291 dwellings, displayed in yellow, have decided not to install any measures at this time. Within another 9 buildings, or 179 flats, the decision-making process is still ongoing. This means that the final voting will be after the project ends. By looking at the numbers of buildings and apartments, we get a first idea about the influence of the building size for achieving a successful renovation project, or the necessary time to achieve a common agreed result. This slide now presents the saving achieved by installed or agreed measures, as well as the saving potentials of these case studies, where the decision-making process is still ongoing. Looking at the blue segments, you can see that the installed measures are expected to save 255,000 kilowatt-hours of primary energy, respectively 72 tons of CO2 emissions per year. Another 590,000 kilowatt-hours or 161 tons of greenhouse gas emissions will be avoided by those measures which are agreed and going to be implemented in the near future, displayed again in orange. So this means a total amount of almost 850,000 kilowatt-hours primary energy savings per year, or 233 tons of greenhouse gas emissions. Divided by the number of dwellings, the average results are almost 3,400 kilowatt-hours, respectively just under 950 kilograms per year and flat. Finally, the gray segments in the graphic sum all potential savings identified in those case study buildings which have not decided whether they are willing to invest in building renovation or not. These saving potentials are more than 940,000 kilowatt-hours primary energy or 149 tons CO2 emissions per year. Also, it can be assumed that all these potentials will not be implemented. Further savings are expected for the LEAF project. So now we would like to introduce some examples of our case study work. Starting with the French case study building in Saint-Étienne, which was the first one that implemented energy efficiency measures. The small block, which you can see in the picture, contains 4 flats. 2 are owner-occupied, 2 are privately owned, and rented by one landlord who also initiated the project. In Saint-Étienne, supply of apartments far outstrips demand. Therefore, the main motivation was to raise the attractiveness of the flats on the market by having a good EPC rating. The other owners were engaged due to continuous support provided by the local energy agency, which convinced the community from the huge saving potentials of this property and the most attractive funding opportunities. Finally, they have installed outer wall insulation, including new windows, roof and floor insulation, and replaced the old heating boiler. By this, the total savings are expected to be 72%. The case study in Vienna consists of two 1974 building blocks. All 29 dwellings are privately owned, but only 15 are owner-occupied. The others are rented. Additionally, there is one owned flat by the community, which is rented to a building caretaker. Since the buildings are now more than 40 years old, the roof covering needs to be renewed. Additionally, the plastering of the outer facade needs repairs. Hail and also woodpeckers have left traces, as you can see in the pictures. The community has already renewed the windows and installed a new gas boiler in 2008. Last autumn, the owners' community agreed to install top floor and basement ceiling insulation. The main motivations were available funding, improvement of thermal comfort in the ground floor flats, and mold problems in the top floor apartments. To be able to combine necessary repair work and energy improvement makes them more cost efficient. The expected primary energy savings are roughly 110,000 kilowatt hours. The reduction of CO2 emissions are about 22 tons per annum. Telford in Edinburgh is a Scottish case study building which is partly owned by a social housing association and partly private owned. The total consists of 12 flats. Since social landlords are expected to meet the so-called EESSH standard, which stands for Energy Efficiency Standard for Social Housing, by 2020, they are convinced to building renovation. The key measure installed was external wall insulation. The motivation behind the selection of this measure was the availability of funding due to Scottish Government, local authority and housing association, which covered the entire costs of the measure for the householders. Other motivations include significant benefits to the householders, such as increased level of thermal comfort, reduced heating costs, improved appearance. The short window of availability of funding meant that resident engagement needed to be swift and effective, with little opportunity for long-term planning or consideration on the part of the residents. The average savings of CO2 is 2.28 tons per flat and a total of 13.66 tons for the building block. Since less than half of our case study buildings were able to make a decision, we were confronted with many barriers through our project work. So here are some examples for buildings which could not be convinced to, and the main barriers which could not be overcome. In the Hungarian case studies, a lack of available public funding is the main challenge for building retrofit. In 2 out of 4 case studies, the LEAF project was able to engage the community in order to select appropriate measures for these buildings, but the final agreement to implement these measures depends on the availability of public funding, since owners are not able to finance the aspired renovation work on their own. Therefore, the community is in a waiting position. Another barrier identified, but also in other countries, are long payback times due to low energy prices. In the Lyon case study building, which you can see above, the main challenge was the engagement of the owners. The owners' community meets only once a year, having a general assembly. Since most act as landlords and don't live in the building, there's hardly communication between these meetings, and regrettably, one motivated owner passed during the project. Furthermore, working with private landlords does also mean that the owners do not benefit directly from the renovation, but have to carry the cost. Being located within a protected area, refurbishment needs special permissions and made the project even more difficult for the community. So working closely with the case study buildings enabled us to identify key challenges to improving the energy efficiency of apartment blocks across the partner countries. The main challenges and barriers are presented as follows. Crucial for a succeeding renovation project is having a motivated person, or in larger buildings a steering group, who is willing to take a leading position. To engage critical residents, it was helpful to connect renovation action with necessary maintenance work. This will reduce disturbances and lead to a better cost effectiveness. To provide appropriate information for residents is probably the most important step to prepare decision making. And to prepare this information material, continuous communication about the request and consent of the individual residents is necessary. This helps also in securing trust and to find the most suitable renovation measures. Building communities have defined processes for meetings and decision making have a better starting position. It was felt that self-organizing communities are more difficult to accompany, especially when meetings are irregular. And having buildings located in restricted areas, best practice examples can be supportive. And of course, the availability of attractive public funding is a supportive factor. We would also like to recommend to present the renovation concept together with a financing strategy, which allows the breakdown to monthly costs. This is easier to understand for the owners and does not act as deterrent as a high figure for total investment cost. Key barriers concerning motivation and engagement are high turnover rate of residents, as well as a great share of private landlords who do not benefit directly from reduced energy costs or comfort aspects. When energy tariffs are low, energy efficiency is sometimes not a priority. In some case study buildings, it was very difficult to maintain contact, especially when the whole process is lasting for years. Restrictions connected with protected buildings and necessary permissions can be a key barrier as well, especially when a high EPC rating does not respond, maybe because there are too less flats on the market. This is also a hindering factor. And of course, again, a lack of available funding sources. Either this is connected to public funding or low maintenance funds are barriers as well. And finally, one objective of the project was to evaluate if EPCs are the right mechanism to trigger building renovation projects. From the perspective of the LEAF project participants and acknowledged by the stakeholder view, the impact of EPCs in respect to trigger improvements in the energy efficiency of multi-occupancy building is seen very limited. The evaluation exhibits the overall understanding of the content as well as the quality of recommendations as major weaknesses. Recommendations for improvement measures are often poorly presented in the EPC and frequently too vague in respect to a specific building. Furthermore, we experienced significantly different calculations for one building, where 3 EPCs were available, and depending on the assumptions made, the results vary a lot. This was a main barrier in this building. And in countries where single dwelling EPCs are carried out, it was mentioned that recommendations regarding the common building parts were totally missing. So I think we have some time for questions after the next presentation. So I would like to say thank you and hand over to the next presenter